Hey everybody, in this video we're going to go over lesson 2.4 in the algebra book, how do we solve multi-step inequalities. It's really nothing new. You've already done all of these skills in chapter 1 when we did multi-step equations. We're still going to distribute, we're still going to combine like terms, we're still going to add or subtract on both sides, we're still going to multiply or divide on both sides. The only thing we might need to know is when to flip the inequality symbol, and we talked about that in lesson 2.3. You only flip the inequality symbol whenever you multiply by a negative number or if you divide by a negative number on both sides of the equal sign. So I apologize, this glare from the lights is going to be in my boards, but here are some examples. We'll run through these pretty quickly. This is going to look exactly like chapter 1, we saw this exact question, except maybe it looked like this, right? This exact same type of question. Obviously, I don't know if it was the exact same problem, but here with the less than symbol, it's still the same, right? I have the letter B, which is being multiplied by 4, and it's being subtracted with 1. My kind of checklist is to do the adding and subtracting part first, so instead of minus 1, I can undo that with adding 1. Whatever you do on one side, you do the same thing on the other side. Usually I say one side of the equal sign, but this is a greater than or a less than sign. Whoops, and see even old habits there. I put in equals just because that's what I'm used to doing. It's actually the less than symbol. Over here, negative 1 and positive 1 cancel out. You have 4 times b is less than 8. You divide by 4 on both sides, and boom, your answer is b is less than 2. Super simple, right? We've already done all these skills. Here, you've got the 9, which is being multiplied by the c, negative 9 actually, which is multiplied by the c, and we've got this 8 out here. I want to undo the 8. Do not see this and think you want to do adding. Excuse me, does this equal 0? Look, up here we canceled it out because it equaled 0. This does not equal 0. So you do not want to add. You want to subtract 8 because 8 minus 8 will equal 0. I cross it out because it equals 0. I don't just cross it out for fun. Negative 28 minus 8 is negative 36. The symbol is still here. We have this minus sign, which kind of just drops down to become a negative. Negative 9 times c. This is being multiplied here. There's multiplying in there. So the opposite of multiplying is dividing. The inverse operation is dividing. Now, look what I just did. I divided by a negative number on both sides. That is my clue that I need to flip this symbol around to the less than or equal to, and then 36 divided by 9 is 4. So whenever you divide by a negative, or if you multiply by a negative on both sides, you're going to flip the symbol. That's what we did in lesson 2.3. Number 3, don't get nervous because they made it look like a fraction. That is okay. We can handle that. Instead of adding 11, I want to do subtracting 11. I can still do that, not going to be a problem. 12 minus 11 is 1. The symbol is still here. My n is being divided, right? A fraction is a way of showing division. So instead of dividing by negative 2, I want to do multiplying by negative 2. Look what I did on this one. Over here, some people put a 1 underneath it to make it look like a fraction. You can cancel it out. We multiplied by a negative number on both sides, negative 2 and negative 2. Anytime you multiply by a negative on both sides, you have to flip the symbol. Just like when you divide by a negative on both sides, you have to flip the symbol. This one got kind of wiped out by my board. I think this is a minus v. If it wasn't, I'm just going to act like it was. So the v is being kind of divided by negative 3. We have this 5 here. I want to get rid of the 5 first. I'm going to save the variable for last. So 5 minus 5 will equal 0. Don't do plus. The plus would make it equal 10. And so 5 minus 5 is 0. Here 6 minus 5 is 1. And then you can drop this down. Negative v over 3. This is the same thing as v divided by negative 3. Don't get fooled. If the negative is up here, sometimes they'll put the negative on the bottom. Sometimes they'll put the negative out in front. It doesn't matter. It's just a negative. And so instead of dividing by negative 3, we're going to multiply by negative 3. I'm going to put it in parentheses just so you don't get it confused with subtracting. Here it cancels out. And here negative 3 times 1 is negative 3. But look what I did. I multiplied by a negative on both sides. So that means I have to flip this symbol backwards. And instead of the greater than symbol or equal to, I'm going to make it the less than or equal to. Now, in my opinion, this just hurts my eyes because it's written backwards. You see how the v is at the end instead of at the front? So if you wanted to rewrite this whole thing and flip everything again, flip the entire thing, not just the symbol, flip the entire thing, this makes a little more sense to my brain than looking at that, just because it's written backwards. Okay, I went from 4 to 7. That means I skipped one. And there's number 6. Here's number 5, and the boards kind of rub off on each other. I'm sorry that my numbers and variables are getting kind of scribbled out there. Sometimes when they want to be tricky, they'll put variables on both sides. Don't panic. We know how to solve an equation with variables on both sides. So we also know how to solve an inequality with variables on both sides. Step number 1, I like to undo the variable from the right-hand side. I do not like having variables on the right-hand side. Whoa, did not mean to do that. Just like here, where I rewrote the variable was on the right-hand side and it confused me, so I flipped it. Here, I don't want to have this variable over here. So if they have variables on both sides, my first step is to undo the variable from the right-hand side. I can do 3x minus 3x. That's going to equal 0. So over here, I better put x's underneath the other x's. I would never put a 3x, a minus 3x underneath a 12. Those aren't like terms. So here 5x minus 3x is 2x's. The minus 12 just drops down. The symbol just drops down. Here 3x minus 3x is 0. 0 minus 4 is negative 4. Now, once you've done that first step, this is exactly like all of them that I've shown you in this video so far, right? I've got adding or subtracting that I can do first, and then I'm going to have multiplying or dividing that I can do to undo that right there. So instead of minus 12, I want to do plus 12 on both sides. That equals 0. This equals 8. And then at the very end, this is where you need to decide whether to flip the symbol or not. Look, I'm dividing by a positive number, positive 2 on both sides. So I'm not going to flip it, and I'm going to keep it as x is less than or equal to 4. So when it has a variable on both sides, just get rid of it on the right-hand side at the very beginning. And then once you do that one extra step, you have the exact same question that you're used to seeing on all the easier ones. Okay, same thing here. We have the variable I'm going to get rid of first, but actually I need to distribute. Anytime there's distributing, I need to do that. So 2 times k and 2 times negative 5. Now I can tell there's something weird about this one. You see how the amount of k's is the same? We have 2k and 2k. Whoops, this is supposed to be a 5. This is going to mean that I have a strange answer, because look, I want to undo the variable from the right-hand side. 2k minus 2k. I meant for it to equal 0 over here, but look what happens. I did not intend for it to equal 0 over here, but 2k minus 2k over there is also 0. And so I have this statement. Now, just ask yourself, is this true or false? Is negative 10 less than 5? That's a true statement, right? That is definitely a true statement. So if you get a true statement, your answer is all real numbers or infinitely many solutions. Either one of those would be fine, right? Infinite solutions. Either one of those is okay. If this was a false statement, like if we had negative 10 is greater than 5, then we would say no solution, because sometimes they'll throw those in there to fool you. Okay, and last but not least, I realize I'm going kind of fast on this, so feel free to pause and rewind the video. Here's another one. I have distributing. Let me do the distributing first. 3 times 2a is 6a. 3 times 1 is negative 3. The symbol is still there. This I'm just going to copy down because I'm not messing with it right now. Okay, I have variables on both sides, so I'm going to undo the variable from the right-hand side. This is the variable on the right-hand side of the question. I want to undo that. Instead of 10a, how can I get rid of that? I can do minus 10a. 10 minus 10 equals 0. Don't look at this. This goes with the 11. If you tried to add, 10 plus 10 would equal 20, and that's not what you want. You want this to be 0, and 10a minus 10a is 0. Okay, 6 minus 10 is negative 4a. The negative 3 is still there. The sign is still there. 0 minus 11 is negative 11. And now this is just like what we have been doing. Instead of minus 3, I want to do plus 3. On both sides, I'm going to do the adding and subtracting part first. And then here I have a multiplying part, negative 4 times a. So the opposite of multiplying is dividing. And when I divide, I'm going to have to flip the symbol, right? Because I divided by negative on both sides. So I'm going to flip the symbol around, and then negative 8 divided by negative 4 is 2. Okay, I realize I went really fast on those. Feel free to stop and pause the video and rewind it. But I wanted to end this up here before too long. And the day's about to be over, so the bell's going to ring and kids are going to will be being loud in the hallway. So thank you so much for watching this. We're going to post an assignment on the Big Ideas Math for you to get caught up. And I will catch you all in another one. See you.